Now that we know how stockpiles are made and the safe and proper ways to acquire representative samples, we are ready to identify our sample, transport it to the lab, and reduce the field sample for testing. This next segment will cover these topics. We'll begin with a video demonstrating proper sample reduction procedures for fine and coarse aggregates. Sample reduction procedures begins on page 45 in your manual.
Are generally difficult to obtain. Producers do not like to stop the belt because of loss of production time, difficulty in restarting a loaded belt, and the need to dig out the crusher. In reality, many samples are taken from stockpiles. Because of the difficulty in taking representative stockpile samples, the importance of following the proper procedures cannot be overemphasized. Samples from trucks, rail cars, and barges are the least desirable of these three options. Whenever possible, it is preferable to sample from the stockpile or the belt. When samples are taken from the roadway or other points of use, it is important to understand that the gradations obtained may be influenced by placement techniques and may not represent the material as produced. Let's begin with taking samples from conveyor belts. There are two types of belt samples that we should consider: belt cross-section and belt discharge. Belt cross-section samples should be taken while the belt is stopped. As mentioned earlier, it's difficult to stop the conveyor belt during production because of several problems. The main elements of belt sampling include sample between two templates that fit the cross-sectional shape of the belt. Collect all of the material on the belt between the two templates. Use a brush to collect all of the fines. Collect 3 samples and combine them into one field sample. Let's follow the belt sampling procedure as demonstrated here. The belt has been stopped and the required precautions taken to prevent the belt from being restarted while the technician takes the sample. Remember, do not sample from the initial discharge onto the conveyor belt. Based on the load on the belt, the technician selects places on the belt for the templates and inserts them all the way to the belt. If templates are not available, the aggregate at each end of the sample area is completely pushed away from the sample. All of the aggregate on the belt between the two templates is placed in the field sample container. Use a brush to ensure that all of the fines are collected from the belt as well. Repeat this sampling procedure 2 more times for a minimum of 3 belt samples. Then combine the 3 into one field sample. You can also collect a discharge stream sample from the end of the belt. Pass a suitable container through the entire width of the discharge stream. A clean bucket on a front end loader often works well as a sampling container for belt discharge samples. At some locations, a sample thief is available for sampling belts or discharges from bins or hoppers. The container for the thief must be capable of holding the entire discharge of the sampled material without overflowing. Belt sampling for fine aggregates and road base is similar to sampling for coarse aggregate. Never sample from the top of a bin or hopper. Bridged material may collapse and cover you while sampling. Remember to work safely while taking samples. You will commonly be required to sample a stockpile. Because the methods used to build the stockpile influence the distribution of particles within the stockpile, proper methods must be followed to obtain a representative sample. It is helpful to understand how the stockpile was built when you plan where to sample. Remember that particle size may vary both horizontally and vertically within the pile. Before we talk about how to properly sample from stockpiles, let's review how stockpiles are built. and how the method of stockpile building influences variations in the gradation of the material in the stockpile. The mast stacker and radial stacker builds a tent or elongated tent-shaped stockpile. A fixed conveyor builds a cone-shaped stockpile. Generally, segregation is worse with cone-shaped stockpiles than with tent-shaped stockpiles. In addition to these influences, segregation occurs due to vibration on a moving conveyor belt. The segregation is then made worse when it comes off the uncontrolled end of a conveyor as shown. The fines tend to drop straight down from the end of the belt. The larger particles tend to fall farther away from the conveyor. As a result, the stockpile segregates into two areas. The side closest to the conveyor tends to be finer, and the farthest side coarser than the gradation of the overall production run. Let's move on to a review of taking samples from stockpiles. There are three basic rules for sampling a stockpile. 1. Remove the outer shell of the stockpile with a front-end loader. 2. Take samples at right angles to the flow of material into the pile. 3. Take several bucket loads with the loader from across the face of the stockpile to represent the cross-section being sampled. Remember that material must be obtained from near the interior as well as both outer faces of the stockpile. The loader bucket samples may be combined into one pile and mixed. When building the pile, keep the bucket of the loader as low as possible and roll the material out of the bucket rather than dumping it out. Limiting the distance the material falls from the bucket helps to control segregation. Roll each additional bucket for the sampling pile out this same way. Next, thoroughly mix the sampling pile with the loader. Begin mixing by moving the loader to one end of the oblong pile. With the bucket as low as possible, push into the pile from the end until the front of the bucket is in the middle of the original sampling pile. Slowly raise the bucket and roll it forward to produce a smooth mixing of the material. Now move the loader to the original opposite end of the sampling pile and repeat the mixing procedure. Check the sampling pile for a uniform appearance. If it does not appear to be uniform, repeat the mixing sequence until the pile appears uniform. As an alternate, instead of recombining, each of the bucket loads may be kept separate and sampled individually. One of two methods may be used to take the samples from the sampling pile or piles. For the first method, have the loader back drag the stockpile to level the upper 1/2 to 1/3 of the pile. Use a square tip shovel to take the sample. Insert the shovel to its full depth. Be careful to keep as much of the sample on the shovel as possible. Take shovels full dispersed across the entire flattened surface. Place each shovelful in the sampling container. For the second method, do not strike off the top of the sampling pile. Leave it as it was mixed. Take the samples at approximately the middle of the volume of the pile, which is located at 1/3 of the height of the pile. Take shovels full from around the entire circumference of the sampling pile. Let's move on to a review of taking samples from trucks, rail cars, and barges. It is even more difficult to obtain good representative samples from haul vehicles than it is from stockpiles, because the majority of the aggregate is enclosed by the body of the haul unit. This prevents judgment from being used to determine sample locations and prevents sampling vertically in the aggregate mass. It is recommended that you sample at the point of delivery, not at the haul vehicle. However, if you are faced with a condition beyond your control and you're required to sample from haul vehicles, you should follow these sampling procedures in order to get the best sample obtainable. Begin the sample by digging a minimum of 3 trenches across the width of the vehicle. Make each trench approximately level, 1 foot deep and 1 foot wide. You should always dig a minimum of 3, but more may be required depending on the size of the haul unit and the tonnage involved. From the bottom of each trench, take 7 equal shovels full of aggregate. Of the 7 samples from each trench, take one directly against each of the 2 sides of the haul unit. Combine the material taken from the trenches of one haul unit into one field sample. In this section, we will review procedures for taking samples of bases and stabilized bases. Base material may be sampled from a truck or dumped truckload or from the roadway. If at all possible, samples that you take from the roadway should be taken before the base has been moved in any way or rolled. Sampling before any manipulation avoids the possibility of contaminating the base. In cases where you have no alternative, samples may be taken from the base after spreading and manipulation, but always before compacting. You must exercise extreme care in these cases to avoid contamination. You should take samples from the roadway generally in the way you would from a dumped truckload. Collect 7 samples that are equally spaced across the entire width of the road. Take 2 of the 7 samples from each outside edge of the roadway. Be sure to get the entire thickness of the material, but don't contaminate the sample with any underlying material. You will have to sample from a number of cross-sections to accurately represent the material. Combine all these samples into one field sample. The weight of sample must be adequate to meet the requirements of the test method for which the sample is being obtained. However, you must always collect at least 50 pounds of aggregate. Standard methods of sampling and splitting must be followed. The producer evaluates his production using the test results and statistical control methods. If the samples are collected using incorrect, non-standard methods, as shown here, the statistical analyses will not be valid. Samples collected at different times using non-standard methods will not be comparable.
We'll be right back.